So for the next 3 class, I'll be taking the class and we'll be discussing Attack Navigator and how we can extract TTPs, tactics, techniques, procedure from the raw data, and along with that how we can store and analyze those extracted TTPs and how it is being done in the real world. We'll be seeing in the next 3 class. Along with that, we'll be also seeing the how analyst can make a defensive recommendation to the organization for which they are performing extracting threat intel data. So in this class, as some of few of the slides sir has already covered, so I'll be going quickly with those slides to make a revision that how we can extract attack TTPs from raw data. So far we were working with Intel where the activities were already listed in the threat reports, finished threat reports, which we did in the last class. So how those TTPs were being made by the threat reports must be written by someone like some engineer or some analyst who must have extracted these TTPs from the raw data like the Windows events, logs and the commands and other things as evidence we extract from the attacked infrastructure. So rather than extracting TTPs from the finished already written and already extracted TTPs, we will be looking into how investigator and how an analyst see the raw data in terms of log files or commands and how they process that information and map that information to the TTP in the attack navigator. So this data mostly come from the various data sources which is present in the victim infrastructure, and the analyzing those behaviors and mapping to the TTPs may likely to be focused more towards procedure level, like the logs, the place in the logs where something is happening related to the malicious or the malicious behavior, or if there is something in the commands, if it is performing some action which something like collecting the data or sending data to somewhere else or communicating on some another IP. So such kind of behaviors and the procedures we first analysts extract what all such a kind of mini procedures available in the source data, and then we process the information. Also, whatever we are doing from the finished report that were already processed and analyzed by analyst and presented in front of us, but here in that case this TTP is kind of biased, like the people who is interpreting the data based on their understanding, their expertise, sometimes it adds the bias. In such case, we are supposed to do this analysis all together with multiple cyber threat analysts. So till now we were not interpreting the data from the multiple perspective, rather than there was a report was all perspective clubbed all together as a conclusion and we were extracting data. So in raw data there is a need to collaborate between the analysts in which they will be extracting TTP based on their perspective and the expertise, and then they will collaborate and they will discuss and then they can finalize to some set of TTPs which they have observed, commonly observed. Also, to do these things, there is a great knowledge required with respect to how we interpret the tactics, the intent. So one command may represent encryption or the sending data to some another C2 server. So that can be interpreted with the, if there is some people who is from the other, not exactly the network security guy, and there is a packet capture and there is a packet behavior where people analysts are supposed to extract the TTPs from the packet capture. So a malware guy, a network guy or a cyber risk guy, they may have a different way to look into it, and there is a high chance that if there is a less expertise then they can miss some of the key information which network guy can do, can get the details. So all these things we need to take care of while mapping TTPs from raw to threat intel. So there is to see where to look into the raw data, there is a broad set of possible data which can contain the behavior. Some of the examples are shell commands, malwares, and the forensic disk images which analysts usually investigate, and the network packets. So as we discussed in the last class, the steps to map the TTPs from any data, either it's a threat report or raw data, there are some six set of steps. First step is understanding the attack, which we already did. All these steps we followed for the threat report, and now we will follow the same way to extract TTPs from raw data. So we will look for the behavior in the raw data, where the behavior lies, and then we can research about the behavior, because the analyst may not have the all broad information, so one can do research on it. And then once we understand what exactly that behavior content present in that behavior do, and then we can translate that behavior into the tactics, like which tactic is mapped to, and then once we finalize the tactic, within that tactics which techniques it is being applied in that behavior, and then followed by we can compare results with our other colleagues or other analysts. So this set of commands sir has discussed in the last class. So it starts with IP-config-all, first command, where one may trying to see the network details like IP and all. Then the next command was SC command, which is used to create and operate with the services, Windows services. Then there is a unknown, very unknown command which we are may not be much familiar with, what exactly this recycle, since recycle to that BSDX, this long command, this one. So this is, by just seeing this, there is a very less sense we are getting what exactly it might be doing. So we will be investigating these commands to see how and what is being done while running this command. So these commands were captured from this small. So this information we will be using to map to the TTPs. Followed by that, there is a behavior captured while performing malware analysis from the sandbox. Like this is kind of IP communicating to some different IP, and the communication is being written from the same on the another side. And following to that, there is a new registry key introduction in the run registry and netsh, which we will be seeing how we can leverage this set of raw data to the TTP. So this is just for the demonstration that the IP-config-all, it lists the details about the Windows, the IP configuration and the Ethernet details. So one can see the details related to the IP, subnet mask, and other details related to the network. So this is the help page for the SC command, which is used to create the service, or you can see there are different syntax example where one can enumerate, display, and the other activities one can perform with the services, Windows services. So after seeing that this SCEXEIN, this PC create, so this is by seeing this we can understand that there is some services being created with this name. So on the server, so you can see example of this. So this is kind of not a correct server address, so it faulted as an error, but it says that it is used to create this service in the registry or service database. So one can do such type of research on the run command, and one can understand that what exactly this extracted behavior is doing. So this researching the behavior, we were doing same in the threat while mapping to the threat report to the TTP. We were doing the same, like we were once we understand where that any process, once we understand any sentence or any paragraph where something is being done, is being represented, then we were researching about that if we are not aware of. So it is bit similar to the previously we did. And then one may require to understand the terminology and understand it, and to help you in researching the behavior, one may require expertise in the specific kind of data types, which can be a network analysis or forensic or malware and other like CMD line tools. Also, one may need to club all data collected from the data sources, and to get the more context, like what exactly, how data collected from the multiple sources are correlated, so that you can understand the flow and understand the how attack was flowed during the attack. So to research the behavior, once you have IP-config-all, one may go directly to the this MITRE web page, and there is a search bar where one can search and see the things. But sometimes these things cannot be such a straightforward. So for the first command, this is too easy. One can go search, and there is a technique named as System Network Configuration Discovery. And all these techniques has a unique ID. So you can see for this technique there is a T1016. So for some of the you can say for some of the commands or some of the raw data, you can get straightforward results or mapping to the technique, and you can map the technique and go ahead. But for a few of the raw data, one need to do research and understand, break the whole information collected in the piecewise to understand what exactly it is doing. So this is more likely the third command which we saw, that recycler one. So after seeing this, the whole command, we can only see that there is something is being, there is a two input and output is being given to this command recycler.exe, but what exactly it is doing, we have no idea, right now at least. So we have to make some of the educated guess, but it's still we are not getting much context of the behavior. So we can run this recycle.exe in the sandbox environment to see what exactly it does. If we run this recycler.exe, this is just an assumption case. So if we run, we can see, we are seeing that this some output like this, which is which is representing that this is something related to the RAR, okay, like compression. So we can guess an idea that there is something compressing or some obfuscation or encryption is being done, which is not clear yet. But once we can see here there is one more switch, there is a flag and the A, which might be representing as an argument for this recycler, and then this flag might be representing what exactly we are supposed to do, and this can be output, this can be input. This is mostly a general behavior we give a command. So after seeing this HP in a flag, it represents the compression or encryption behavior. So one can guess that this recycler.bin old, this is the destination path, where this file, this VSDK file is being encrypted or compressed and being placed here. So which is, we are not sure, but we just guessed it. But when we go forward, what is this VSDK? Look, we resolve this, there is this, we guess this is the destination and the source and destination path. But what exactly is VSDX is? So one can do research on this VSDX on the internet, and we got to know that this VSDX is used it's a Visio diagram which is being used as an input in this command. So there is a kind of more contextual guess now that there is some Visio diagram file which is being complexed or being encrypted, and probably when it is being done, like why attacker will encrypt or compress the file on the victim system. This is kind of used out. So this is mostly done while encrypting the data, so that data size can be less and can get evaded in the network phase while communicating to the CNC server. So there is now we have a little bit more educated guess that this is a kind of stage where attacker collects the data and do encryption or compress it to send it to the CNC server. So now we'll club together whatever we analyzed for all three commands which we saw. So ipconfig all, this is we map directly to the system network configuration discovery. So the tactics which is being used here is discovery, and technique is this. Also we noticed that this command, all three commands were extracted from the sysmon. So this sysmon is also represents the execution behavior, like these commands are being executed in the victim machine. So there is two tactics which we discovered from this command, discovery and the execution. Further, this recycler command, after figuring out this VSDK is being compressed using this recycler, we can connect it with the exfiltration phase, which is a kind of a strong evidence that exfiltration might be being done, and also this sysmon, as we extracted from the sysmon events, so this is related to the execution tactic. Okay. So the fourth stage is now figure out what techniques applies. For some of them we already saw that. So this is also similar to the like threat reports mapping. We have to go to the attack database, knowledge base, and once we understand the tactics or the behavior, we have to look into the techniques, which techniques it has been used, which is kind of straightforward again for the ipconfig all. Plus all these commands is being run on the command line. So there is one more technique named as command line interface. If things is being run on the command line, using the command line, so this is the technique represents to that behavior. So this technique and this technique finally got mapped to this, and this command line interface comes under the execution tactic. Further, this recycler command, as we figure out that this SP and command A is representing to send the argument and the denote it as to perform the compression or encryption. This is appearing to be a data compressed phase. This is a technique is present in the collection tactic, and or it can be data encrypted, which is not clear yet, and further this is again aligned with the command line interface T1059. Okay. So now we understand that we extracted some of the techniques for the first few of the commands which we saw. Now we have to see these techniques, now how these techniques is being like happening. To understand that, we have to the techniques can occur concurrently. So it's like we saw that execution and the like if ipconfig all, so execution and discovery is happening. Similarly, the compression, if they are performing two techniques together, something like you can see one can receive the spear phishing attachment once user executed that or double click or open that. So that will comes under the two tactics, initial access and execution, and there will be two techniques, spear phishing attachment and the user execution. So the two techniques can occur all together. So once we understand the one, to look into the other aspect of the behavior, whether we can extract multiple techniques from the single behavior or not. So there can be chances that two multiple techniques can exist in a single behavior. Similarly, data from local system can be collected and the email can be collected all together, which comes into the collection phase. And as we saw in the, no, we didn't saw, but process discovery and command line interface, both of these can occur all together with the two different tactics, discovery and the execution. Okay. So now in the MITRE attack knowledge base, we have total approximately, if I remember correctly, 190 plus techniques divided over the tactics which we saw, but all techniques and all TTPs are not equally they don't have equal weightage in any attack phases. So there are some of the techniques like the command line interface which saw that is mostly being used by all adversaries. So that is being mostly used TTPs out of all TTPs we have. Also, the TTPs can be directly as a straightforward, like there are some TTP, if run DLL is being used to execute any DLL file, so they are directly mapping to technique to the run DLL. There is also NetSH, if any DLL is trying to do something with the network detail, then this NetSH helper DLL being executed. So this too is the example of a straightforward mapping. If you are seeing anywhere run DLL in your behavior, that can be directly mapped to the technique run DLL, and the similar goes for the NetSH DLL. But some techniques can have a broader aspect like scripting. Scripting can be, in the scripting technique, one can do anything, like one can use PowerShell, one can use other scripting like Python or to develop the executable or payload. So scripting kind of a broad which is again breaked into the sub techniques which we'll see in the knowledge base detail, probably in tomorrow's class or today's class. So these techniques named as obfuscated file or information. So what it is representing is file or information is being obfuscated, but how and what is being done exactly is not clear. So this techniques, like one can do compression, one can do encrypt, one can hide that in some hidden folder or as a hidden item in the window machine. So this is still it is not cleared, not exactly specific detail how obfuscation is being done. So there are some techniques which are having a specific detail and some are very broad. Also, there are some techniques which help us to understand how this behavior occurs. So one can masquerade mostly malicious files masquerade themselves as a benign or legitimate process name. So mostly SVC host in the window. So one can masquerade themselves, and this is showing how attackers is masquerading, like behaving. The behavior comes, there is nothing like any procedure is happening there, then it is just masquerading them with their name. So we need to see also how any behavior, there is some techniques which represents that not exactly something is being done rather than how it is being done. So this data transfer size limit and the automated collection, all these things comes into this category. Now, as we discussed this earlier, that the way to look into the data set and translate it, research it and map it to the TTP can have different results for the different analysts having different perspective, different expertise. So one threat analyst needs to get collaborated with each other and do collaboration to understand others' perspective and finalize the set of TTPs or modus operandi observed during the attack. So in one example, analyst may have more expertise related to the analyzing the packets or doing reverse engineering or more friendly with the Windows command line, rather than the other analyst may have expertise related to the Windows event analysis or forensic, or that analyst may be more comfortable with the Mac OS or Linux. So in such cases, if you have a machine with the window, high chances that this analyst 1 can get more contextual and broader information of the behaviors, and he may have more understanding of the mapping the behaviors to the TTP, rather than if there is something related to the forensic, analyst 2 may have better insights rather than analyst 1. But also we cannot go with the 1 because there any attack may have a clubbed information of all these things needs to be analyzed. So this is a general way which follow in the real world, where multiple analysts collaborate together to discuss and finalize the TTPs. So why we do this? So basically there is a term of profiling the adversaries. So this TTP majorly represents the modus operandi of the attacker, like how attackers usually behave to achieve some target. So assume there is attacker A and B, and attacker A is mostly trying to get initial access into the victim machine, and attacker B at the same time is trying to get the access of the victim machine. So the behavior of the attacker A can be, if we have profiled in the by analyzing the past attacks, so this can be seen that the attacker A is trying to mostly send this spear phishing email to the victim, and they try to get into the victim infrastructure. Either user clicked on the sent or spear phished email. So why we are extracting these TTPs from the raw data, how it is going to helpful in the real world. So we took a case for attacker A and B, where attacker A generally follows the spear phishing techniques to phish the user or the victim, get into their network or system, where the attacker B is more sophisticated and they develop a zero-day vulnerability, or they exploit any public-facing applications of the victim, and they invade that, and then they get into the network or system. So this can be two different behavior which is being used by two different adversaries based on their expertise and their knowledge. This helps us to segregate the behavior or the modus operandi of the attack groups or the threat groups, where we can see a set of TTPs which one attacker group follows usually, and what other attacker group is being followed in the past years. But obviously this can be changed. One can follow, one can mimic the behavior of others, because this TTPs and behavior is all publicly available. One can follow other groups' behavior to masquerading their identity. This is mainly helping in profiling the threat group's identity, or the profiling their behavior. So let's understand what is the pros and cons of mapping TTPs from the raw data and the finished threat report. Okay. So the first stage was finding the behavior. For raw data, we were nearly exactly to the behavior which is being demonstrated in the attacker victim infrastructure, but in the finished report, it may be buried amongst pros and IOCs. So attackers, in the threat reports, we directly have a list of IOC which is being listed in the threat reports generally, and things are directly already analyzed and placed in front of us. In the research behavior stage, for the raw data mapping case, one need to collect the data from the all multiple data sources and different data types. Also, this can be helping to first understand the procedure before going to the tactics or techniques. Whereas in the finished threat reports, we may have more information and the context as is already been analyzed and described after the analysis, threat analysis. More information and the contextual information in the threat report rather than the raw data. Okay, but this information, whatever is present in the threat report, is totally based on the understanding of the analyst who has written the report and performed the analysis. So there are chances that there may be a loss of data while writing the threat report, rather than in raw data we will be having all possible behavior and the evidence in front of us, and we can perform analysis based on our expertise. While for translating the behavior into the tactics, we have to map to the adversary intent, and for that one needs to have a domain knowledge or expertise, rather than for finished threat reports, Often this intent has been already processed and postulated and by the report author and has been placed directly in front of us. Now, while figuring out the techniques, which techniques has been used in the attack, for the raw data, we may have a procedure which directly straightforward as we saw for ipconfig, or one may require a deep understanding of the domain knowledge from where we are mapping the TTPs and understand how it is being accomplished. So, for this one need to have a deep understanding of the domain rather than in finished report. If you want to map to the TTP, there is a domain with the help of the NLP, natural language processing. One may process the text, understand what exactly being explained in the sentences of the threat reports or the description, and one can let an NLP model to understand the behavior and the from the sentences of the threat reports, and one can develop a model where we can map directly from the sentences, threat report sentences to the TTP. So, but this can also be a kind of complex thing which one need to understand, which one need to train a model, an NLP model, where one need to let the model understand the contextual information of the sentences and the paragraphs, and then this text match also may help in the mapping to the sentences to the TTP. Now, for comparing results with the another analyst, one may need to multiple analysts to cover all kind of different data sources present at the victim ends. In the finished threat report case, it is more likely in the form of that other analysts already needed for the coverage to hedge against the bias, means to restrict the bias. An analyst need to having a more kind of diverse coverage and understanding of the domain, so that they can understand the sentences and written in the threat report and map it to the attack navigator. So, now there is an exercise where we will be directly will be seeing in the further slides, but it is expected that students can go to this link and access the exercise and do it after the class. So, there is exercise at this link under the exercise 3, where there is 2 tickets 473 at 22 and 473 at 45, which has a series of commands and piece of malware analysis, primarily a remote access Trojan. And you have to see the series of commands present in this ticket, and you have to map those commands to the TTPs present in the MITRE attack knowledge base. So, these commands are mostly executed by cmd.exe, which is kind of presumable, and the other piece ticket that 473 at 45 is a piece of malware analysis of a remote access Trojan, which is being used in some past attack. So, we have to go to this website, access the stored tickets and analyze and map the commands to the TTP and the pieces of whatever malware information there is listed in that ticket, map that to the MITRE attack TTP. Now, okay, you have to record your results and download and edit. Then you have to identify as many behavior as possible from the commands on the malware analysis behavior, and you have to annotate those behavior on the MITRE attack techniques on that document. Further, we will also see, once we have this set of TTP, how we are going to store and analyze in the next few slides. Okay, while performing this exercise, you have to understand that if you are an analyst, what you are supposed to ask, what has been asked to the incident responder to get that behaviors. Whatever behaviors is being present in the ticket, you have to understand that. Then what was easier or harder for working, if you are working with the raw data and you are working with the finished threat reports, you can feel a difference between how easy and how hard it is to map a TTP from raw data and the finished threat reports. Then you can also look into that what are the type of data which you commonly encounter with the behaviors. So, once we do this exercise multiple times, we can have a TTP on that fingertip. We can understand which kind of TTP is being used mostly by the attackers or which threat group. Also, while exercising, did you notice any behavior that you could not find for a technique for? So, there can be some behavior for which there is no tactic listed in the MITRE attack knowledge base. So, it is kind of interesting to see, can we find some behavior which is being not mapped to any TTP. Okay. So, this MITRE attack knowledge is being updated continuously since last few years. So, each year they add different techniques and they club multiple techniques in one category. So, some behaviors present in the current situation for which there is no TTP at all. If one can find such TTP, such behavior, one can, MITRE has a one channel to report such techniques or behavior to them, and they may list that if they analyze that, and if it is found true behavior which they might be missing till now, so they may add that to the attack navigator or knowledge base, and by giving credit to you obviously. Okay, so we'll directly see the result of the TKIT 47382, which contains the set of commands. So this is exercise you are supposed to do after the class, but I'll just demonstrate and explain the things to you, having a better understanding of mapping. So as we did earlier, ipconfig all, it is directly having a technique T1016. Next, ARPA. So this can send to translate the IP and the finding the system in the network. So this can be a system network configuration discovery. So then further there is echo user domain and username. So probably it is trying to print the user domain and username of the machine. So this can map to this system owner or user discovery, which having a technique ID T1033. Then task list -v, which is mostly being listing the running process in the machine. So this is going to map to the process discovery T1057. Then there is one more command, SC query. This is kind of querying the service state or their what exactly they are doing. So this can be listing out the this can come under the class of TTP system service discovery having ID T1007. Victim may run this command system info, which has been listed in this ticket. This system info gives the output about system information, so that can be mapped directly to information discovery T1082. Then there is one more command, net group domain add domains, which can be used to see the group's permission, whatever groups present on the victim machine. So this can be mapped to the permission groups discovery, which is T1069. Then there is one more command, net user domain, which can be used to see what all accounts present on the machine, that can be mapped directly towards the account discovery. Also there is one command related to net group domain controller, which can be used to see all the groups present on the remote domain controller, where one can map that to the remote system discovery. Further, netsh add firewall so all is represents to list out the what all kinds of firewall related details available implemented on the machine. So this also again is related to the network configuration, and it is being mapped to the system network configuration discovery. Okay. Then the final one is netstat ANO, which lists out the all network connection is actively communicating to with the victim machine. So this can be listing out, this can be mapped to directly to system network connection discovery. So you must have seen a common pattern that we are understanding what exactly this command is doing, and based on our knowledge of attack knowledge base, we are finding where this lies in and we are directly mapping it. And also if you see, all these techniques present in these tactics are related to discovery stage or discovery tactics, in which adversary is trying to list and collect see information related to the victim machine, and which is being mapped towards a discovery, performing discovery on the victim machine. Also, as this all commands is being will be either using a PowerShell or the CMD on the victim machine, so that will comes under this tactics of execution, and mostly it's a command line. Okay, so in the execution it will get mapped to the T1059, which is used for running the commands line interface or the PowerShell commands. Similarly, the next ticket 473845, for this we have this set of behaviors present in the ticket. So we'll first see this C2 protocol. This C2 protocol is base 64. So here this C2 represents the command control, where base 64 is a standard protocol is used to encode for data encoding. So attackers sometimes they encode the data or to obfuscate their real information. So in this we can map that data encoding present in the command and control tactics directly. Also, as this is the standard application layer protocol, one can use this, one can map this to the T1071. Further, there is information related to uploading the file from server to client, like from victim machine to C2 server. So, this can come under the remote file copy where T1105, or this can also happen from victim server to attacker server to victim machine, that is client. That comes under this downloading the file when victim adversary downloads the file or malicious payloads hosted on the attacker's C2 server. Then there is shell command where some shell command is being run in the environment. So, this can be mapped to the command line interface again. Then there is a P shell, and which can be again which runs the command via PowerShell. So, this P shell command can get mapped towards the PowerShell 1086 execution phase. Further, there is exec path, which represents the path of any P executable and which is being used using this API. So, because of that, this can map execution through API technique present in the execution tactics. Now, we can see this IP is being communicated to this, and there is a reverse communication, but we may not get much detail from this communication. Rather, only we have this port number 443. Okay, so this is the standard port for the HTTP communication, and this is kind of non-standard port. So, this port number can get mapped. There is one more technique. If attacker is using some commonly used port number, so that presents under the command and control. If they are using any commonly used port to communicate with the command and control server, so there is a technique. So, we can directly map T1043 for this kind of behavior. Okay. Now, there is copy command where even spool is being renamed with some another thing which has been hidden here. So, where this one sometimes attackers masquerade and they rename their file with something else with some another extension. So, you may not be realizing that the extension with .pdf file is actually executable file. So, such kind of behavior is representing masquerading, and there is a technique for that in the defense evasion tactics. So, this is T1036. Further, there is a registry information. If you can see, the modification is being done in this registry named as run, where this win spool which they have renamed just now, they added that into the run registry. So, run registry mostly contains the list of items which is supposed to run, which is supposed to get executed or pointed out once machine is getting, once we are rebooting the machine. So, this represents that they are trying to make a persistent connection where they are modifying the registry run key, and there is a specific techniques for 60 which is present in the persistent tactics. Okay. So, you can see this registry is given path to C window, this path which they have just now they renamed it. Okay. So, till now we talked about documenting the reports with the attack, how we can understand and map the TTPs from the threat report. Also, we discussed till now that one can use the raw data, analyzing data, attack to mapping the TTP. These things can be done in parallel. So, this mapping from information to the TTPs, it allows the other analysts to examine the mapping for themselves. Also, it allows the easily capturing the how techniques were done, which we have seen while mapping the things. Okay. So, in the most of the threat reports, if you see some of the reports from the prominent companies already list the behavior in the threat report. So, rather they wrote the whole threat report explaining the behavior. In the last, they can give some appendix or list of techniques which has been seen in the whole attack. So, this IP, if they have written some sentence like this: during operation Tangerine Yellow, the actors used pineapple rat to execute this IP config via Windows command cell. So, directly it is representing these two techniques which we already discussed. So, instead of writing this set of things, if I want to communicate with the another one, so one can list this set of techniques, like there is a network configuration discovery is being done in the attack, there is a command line interface technique is being done, and there is some if there is a hardware addition they can do. So, this enables the communication between the analyst. So rather than explaining the whole story in the sentences, one can give a set of TTPs has been used in the attack, which can summarize the other analyst or other expert to understand how attack flowed. Okay? Any doubt? Okay. So this is the end of the module. So now we'll see a glimpse of the Navigator tool, which lists out all these techniques, and we see how once we have a set of techniques, how we can use that to storing and analysis purpose. So to as I told that this is used to do the profiling, threat profiling. So the set of TTPs which we extracted from the raw data or from the threat reports, one need to process that to get a understanding and visualization of the TTPs or the attack scenarios. Okay. So we'll see the attack navigator now. So this is just a kind of basic introduction of attack navigator. We will do the whole analysis of the TTPs in the next class. If anyone has any doubt, you can ask. No doubt? So you can go to attack.mitre.org. There is a metrics section. So they have, we sir already discussed this, that we have 3 kind of matrices for enterprise, mobile and ICS, industrial control system. So on the enterprise metrics, we are more interested towards IT system. So we'll go with the enterprise metrics, and there is a tab named as View Attack Navigator. This is the navigator, which is it is openly available. One can use it for their own purpose. So we have a different section here. We'll discuss all these layers different in the next class tomorrow. For now, I'll just show you a quick demo. So this is the whole navigator. You can see where these are the tactics listed one by one, all 14 tactics, and these are the techniques within each of the tactic. So we will see how extracted techniques. We will be mapping here. We will be mapping multiple attacks, tactics all together, TTPs all together, and perform analysis to understand what kind of all common techniques has been used and what all kind of different techniques has been used by 2 threat groups or even a single threat group of 2 different attacks. So that will give us understanding of how attackers is either they are changing their behavior and how they are distinguishing from the other threat groups. Okay. So these all tactics list kind of Reckonance has the 10 techniques and the others. Also the sub techniques which I saw, this command and script interpreter, we saw this T1059 multiple times. So this has the different sub techniques. So one can use this scripting and the command cell to perform the attack, and within this there are multiple ways one can perform these techniques. So these are the kind of subtexts. You can see PowerShell is T1059.001. Similarly, this Python and the other command cell having 003 subtechniques. Okay. So this is the interface. So we'll wrap up now, and if someone has any doubt, you can ask. Otherwise, in the next class, we'll see this navigator tool, how we can store, analyze, and how we can list out the defensive recommendation for the victim. So the next class will be crucial because the second assignment, we'll be releasing second assignment today, and the second assignment has, in the second assignment you are expected to, you'll be giving a report for each group, and you are expected to extract the TTPs from the reports by reading the report based on your group's understanding. And once you have a list of TTP, you can map that to the navigator. You can give a contextual information how you come up with that TTP, and then you are supposed to give the defensive recommendation for each of the attack methods which we have seen in the threat report. So we'll discuss this how to give this defensive recommendation and how to map and perform analysis on the navigator tool and how to add contextual information in this tool in the next class. Okay.